Hello dear students, today we are going to discuss class 11 chemistry chapter number 4 chemical bonding NCERT exercise solution from question number 27. Draw the diagrams showing the formation of a double bond and a triple bond between the carbon atoms in C2H4 means ethene and C2H2 means acetylene. So you can see here C2H4, both the carbon atoms, how the double bond formation is there. You can see how many sigma bonds and how many pi bonds, right? So there will be one pi bond and one sigma bond between both the carbons, and all the hydrogens will be attached with the sigma bond. And you can see below that unhybridized p orbitals, formation of ethylene molecule. Now let's see the formation of ethylene molecule. You can see this ethylene molecule. In this ethylene molecule there are two pi bonds, one sigma bond between the two carbons, and both the side the hydrogen is linked with the sigma bonds. What is the total number of sigma and pi bonds in the following molecule? You can see here the total sigma and pi bonds in the following molecule. C2H2, same acetylene. You can see there are two pi bonds, one sigma bond between both the carbon atoms and two sigma bonds with both the carbon atoms hydrogen attached. So total 3 sigma bond and 2 pi bonds. In C2H4, number of sigma bonds 5, number of pi bonds 1. Now let's come towards the question number 29. Considering x-axis as the internuclear axis, which out of the following will not form a sigma bond? You can see here there are some questions which of the following will not form and why. 1s and 1s, 1s and 2px, 2py and 2py, 1s and 2s. See, 1s and 1s can never form a sigma pi bonding. A bond is formed between the two atoms by the overlap of singly occupied orbitals along their axis. End-to-end overlap is called pi bond. Hence you can see 1s and 1s, 1s and 2px and 1s and 2s will form only and only sigma bond, which are formed by the sidewise or lateral wise overlapping the p orbitals. Hence pi 1, px and py. Remember, px and py will form pi bond and pz will bond sigma bond. Now let's come toward the question number 30. Which hybrid orbitals are used by carbon atoms in the following molecules? You have to just tell the hybrid orbitals. CH3, CH3, in methane sp3 hybridized, sp3 hybridized. Both the carbon atoms are having sp3 hybridization. CH3, CH, CH2. First one, since it is CH3, all the single bonds, sp3 hybridization. Second one is having a double bond, sp2, and third one is also having a double bond, so that's why sp2. CH3, CH2, OH. CH3, sp3 hybridization, and CH2 one is sp3 because it is also linked with the 4 single bond, so that's why it is having sp3 hybridization. CH3 CHO, yeah, the first one is sp3 and second one is sp2, and CH3 COH, first one sp3 and second one sp2. So this was our hybrid orbitals of question number 30. Now come 31. What do you understand by the bond pairs and lone pairs of electron? Illustrate by giving one example of each type. Bond pair are the pairs of electrons taking part in bonding. Means an electron which participate in bonding are called bond pair electrons. So you can see here in sulfur there are total 6 valence electron. In hydrogen sulfide only 2 electrons are bond pair and rest 4 are lone pair electrons. A pair of electrons in a molecule which do not shared by one of the two constituent atom, that is does not take part in the direct bonding, is called lone pair electron. You can see in ammonia there are total 5 valence electron, 3 are bond pair and 2 electrons which is one pair, that is called lone pair electron. Distinguish between a sigma and pi bond. Comparison between a sigma bond and pi bond. It's very important question for the board, even for JE. Now you can see the sigma bond. The bond is formed by the overlap of orbitals along the axis. End-to-end overlap includes SS and PP overlapping. In pi bond, the bond is sidewise overlapping of orbitals, lateral overlapping, it includes PP overlapping. It is a strong bond. Sigma bond is a strong bond, pi bond is a weak bond. It can be free rotation of atoms around this bond. The pi bond free rotation is not possible around this bond. The shape of the molecule is determined by these bonds. These bonds do not affect the shape of the molecules. O electrons are referred to a localized sigma electrons are referred to a localized electron, and pi electrons are referred as a mobile electrons. Now come question number 33. Explain the formation of H2 molecule on the basis of valence bond theory. As I have described this answer in my video also, we can consider two hydrogen atom A and B approaching each other with having nuclei Na and Nb, and the electrons present them represented by Ea and Eb. When the two atoms are at a large distance from each other, there is no interaction between them. As these two atoms begin to approach each other, new attractive and repulsive forces begin to operate. Attractive forces arise between nucleus of one atom and its own electron, that is, first nucleus and first electron, second nucleus and second electron. Nucleus of one atom and the electron of the other atom, NaEb, Nb, Ea. Similarly, repulsive forces arise between electron of two atoms, Ea, Eb, Na, Nb, nuclear of two atoms. Attractive forces tend to bring the two atoms close to each other, whereas the repulsive forces repel them each other. You can see this diagram tend to push them apart. How the hydrogen bonding is formed? Very, very important question. Experimentally, it has been found that the magnitude of new attractive forces is more than the new repulsive forces. As a result, the two atoms approach to each other and potential energy decreases. Ultimately, a stage is reached where the net force of attraction balances and the force of repulsion, and the system acquires minimum energy. At this stage, the two hydrogen atoms are said to be bonded together to form a stable molecule having the bond length of 74 picometer. Since the energy gets released when the bond is formed between the two hydrogen atoms, the hydrogen molecule is more stable than the isolated hydrogen atoms. The energy so released is called bond enthalpy, which corresponds to the minimum is the curve depicted in a figure. Conversely, 435.8 kilojoule of energy is required to dissociate 1 mole of H2 molecule. H2 plus 435.8 kilojoule per mole, hydrogen plus hydrogen. Question number 34. Write the important conditions required for the linear combination of atomic orbitals for molecular orbitals. What are the necessary conditions for linear combinations of atomic orbitals? The symmetry and the relative energies of combining atomic orbitals. A and B must be close to each other. The extent of overlap between the charge clouds of A and B should be large, and the atomic orbitals of the same sign should overlap. Question number 35. Use molecular orbital theory to explain why Be2 molecule does not exist. Beryllium atom has the electronic configuration of 1s2 and 2s2. So in beryllium Be2, there are a total 8 electrons which must be filled in 4 molecular orbitals. So molecular orbital configuration of beryllium, 1s2 in 1s2 you know very well. 1s2 of first beryllium, 1s2 of second beryllium, and 2s2 of first beryllium, 2s2 of second beryllium. So the bond order half into 4 minus 4 0. Since the bond order is 0, it shows that molecular beryllium will not exist. Remember this word. When the bond order is 0 means molecular orbital doesn't exist. Now you have to just indicate about the molecular orbital's magnetic property. Compare the relative stability of the following species and indicate the magnetic property of O2, O2 plus, O2 minus and O2 2 minus. You can see this diagram is enough to represent which are paramagnetic, which are diamagnetic, why they are paramagnetic, why they are diamagnetic. I have already taught you these things in the molecular orbital theory. Come to the question number 37. Write the significance of a plus and a minus sign shown in the representing the orbital. The plus and minus sign indicates the plus and minus sign indicates the sign of the wave function in the various lobes and not that of the nuclear or electronic charge. The plus sign or upward crest represent the phase, and the sign represent the second phase of the wave function. Bonding molecular orbital is formed by the combination of plus with the plus and with part of the electron waves, whereas anti-bonding molecular orbitals are formed by plus with the part of the electron waves. As orbitals are represented by the wave function, a plus sign in an orbital represent a positive wave function and a minus sign represent a negative wave function. Let's come to the question number 38. Formation of PCl5, sp3d hybridization. The ground state and the excited state outer electronic configuration of phosphorus, Z is equal to 15 here. You can see this configuration of phosphorus. You can see the phosphorus in the ground state, 3s2, 3p3, excited state 3s1, 3p3 and 3d1. So PCl5 is possible, right? sp3d hybrid orbitals filled by the electron pairs donated by 5 chlorine atoms. Now the 5 orbitals 1s, 3p and 1d are available for the hybridization to form a set of 5 sp3d hybrid orbitals which are directed towards the 5 corner of a triangular bipyramidal is depicted in the figure. All the bond angles in trigonal bipyramidal geometry are not equivalent. In PCl5, the 5 sp3d hybrid orbitals of phosphorus overlap with the singly occupied p orbitals of chlorine atoms to form PCl sigma bond. 3 PCl sigma bond lie in one plane and make an angle of 120 degree with each other. These bonds are termed as equatorial bonds. The remaining of 2 PCl bonds, one lying above and other lying below the equatorial plane, make an angle of 90 degree with the plane. These bonds are called axial bond, as the axial bond pair suffers more repulsive interaction from the equatorial bond pairs. Therefore, axial bonds have been found to be slightly longer and hence slightly weaker than the equatorial bonds. 39. Define hydrogen bond. It is a weaker or stronger than the van der Waals forces. Very important question for the board. Hydrogen bond can be defined as an attractive force which binds hydrogen atom of one molecule with the electronegative atom, either fluorine, oxygen or negative nitrogen, of another molecule. Following conditions should be fulfilled by a molecule for the formation of hydrogen bond. Hydrogen atom should be linked to a highly electronegative atom such as fluorine, oxygen, nitrogen through a covalent bond. The size of the electronegative atom bonded covalently to hydrogen atom should be small. Types of hydrogen bonding, two types. Intermolecular hydrogen bonding, when hydrogen bond is formed between the hydrogen atom and one of the molecule of the electronegative atom, another molecule of the same compound such as hydrogen fluoride or different compound such as water and alcohol. It is known as intermolecular hydrogen bonding. You can see the diagram of intermolecular hydrogen bonding. And intramolecular hydrogen bonding, when the hydrogen bond is formed between the hydrogen atom and an electronegative atom present in the same molecule, it is known as intramolecular hydrogen bond. Orthohydroxy, benzaldehyde and orthonitrophenol hydrogen bonding is stronger than the van der Waals forces. Last question. What is meant by the term bond order N2, O2, O2 plus and O2 minus? I hope I have already taught you bond order is equal to half into NB minus Na. After calculating from the molecular orbital diagram, you will get all the question answers. What are the bond diagrams or bond orders of these questions, right? I hope we have completed our chapters. And by this chapter completions, I hope everybody had understood about the concept. That's all for today. Thank you very much. Have a nice day.